Okay, so here is the video solution from the problem we did in class on Thursday, where we had a soccer ball being kicked 20 meters from the goal and striking the goalpost, which is 2.4 meters up. And this is all that we know. And I've defined directions. We have up is positive and to the right is positive. So both of our displacements in the x and y direction are positive, 20 and 2.4. Our acceleration in the y is negative, 10 meters per second, because this is free fall. And our acceleration in the x direction is 0, because what we're interested in here is after the ball gets kicked and it has left the foot, and the only thing now acting on it is gravity. So like I agree with you, and you're saying that the ball had some initial velocity at 0 at some point. I agree, yes, but we are interested, like the question says, what is the initial velocity the ball has? I don't need to know anything about the force that kicked the ball, because the connection between these kinematic problems we're doing and the force unit is acceleration, but I know the accelerations, so I don't need to know anything about the force in order to solve this problem. So this is the stuff that's laid out, and remember the time is what connects these two things, because at the time it has traveled 20 meters, it has also traveled 2.4 meters up, so the time is the same for these. So if we're looking also, we are interested over here in the V naught, right? That is our, that is our unknown. That's what we are looking for. So if, as we're looking at this problem, in order to find this resultant vector, right, this non-component, we don't know we would need to know something about the initial y velocity and the initial x velocity, and we don't know. So let's put together some equations that we know. And we said for the x, right, we are going to use the equation that we have. Oopsies. Right, the delta x equals v naught t, but in this case v is v naught and vf, because there is no acceleration, plus 1/2 a t squared, and this thing is going to go bye-bye because the acceleration in the x direction is 0. So we have this delta x equals vxt, and if we come over to the y, we'll use the same equation, but it's unique to the y. In this case, we have v naught y times, times t plus 1/2 a t squared. And as we're looking at this problem, we notice that we're going to have 3 different unknowns, right? We know time is an unknown, but also our velocities, and they're going to be different from each other. This thing is not at a 45-degree angle. If it was, then you would know that they are equal to each other, and that could help you out. But in this case, they are separate from each other, different from each other. So we have an equation here, 2 equations that have 3 unknowns, and this is where you would get stuck. You can't solve this system with just 2, because how many ever unknowns you have is how many equations you need. We would need a 3rd equation, but we don't have a 3rd equation, and they're a different unique equation. That's where it's important for us to recognize that when we are looking at components, this is our v naught y, this is our v naught x, like you're right in calling them v naught x and v naught y, but because we know the angle, we do know a little bit more information about these components. I would say v naught x is actually going to be whatever the velocity is times the cosine of 32, and whatever v naught is, we would multiply it by the sine of 32 to figure out the v naught in the y direction. So write as much as you can in what you know in your components, because now instead of having a question mark here for v naught x, we can actually write a little bit more. We know that it's v naught cosine 32, and we know y initial is going to be v naught sine 32. So if we plug in 20 equals v naught cosine 32 times time, we still have two unknowns in that equation. I do agree with you. Here we have 2.4 equals v naught sine 32 time plus 1/2 negative 10 t squared. This equation still has two unknowns, but between these two equations, I'll use a different color. Between these two equations, we have just two unknowns, v naught and t. So by defining the components of our velocity vector in terms of v naught, we have essentially made this equation only have two unknowns. Now we can solve with a system of equations. Remember, cosine 32 is just a number, so we can get that. And there's a little math thing that we can do here, math trick. You don't always have to solve for one, isolate one variable, and then plug in. If you have a common multiple variables, so if we look at this equation, we would say, oopsies, right, 20 is equal to, right, since v naught is a variable and t is a variable, I'm going to keep the variables together, but I can get a number for the cosine, 8. I think that's a 4. Can't actually read my own handwriting over there, but I think that's a 4 going on. So we have these two variables together. And then I can do the similar thing over here. 2.4 is equal to v naught t times 0.530 plus 1/2. Now just do this math here. We get negative 5. Right, 1/2 negative 10 is negative 5 t squared. If you notice, we have a v naught t and v naught t, right? So it doesn't, if I can isolate v naught t, then I can plug in for v naught t on the right side. It's just a little math trick. You don't have to always solve for one variable. So if we get this, if we divide our red equation here, 20 by 0.848, we get 23.585 is equal to v naught t. And what I can do is take this number and plug it in for this, and it makes us have not a crazy quadratic to do. Like if you were to isolate, probably be better if you isolated t and plugged in for t, but if you isolated for v naught and then plugged in, you'd have a pretty big quadratic to deal with. So this eliminates that. So we get 2.4 is equal to 23.585 times 0.530 minus 5t squared. And we can solve this, I believe in your math skills, that you can solve this equation to get time, and time is going to be equal to 1.42 seconds. And that's not the answer to the question, but it is the answer to how long this ball is in the air for. And what we can do is, now that we have this time, looking at our equation, one of the simpler ones to do, we can plug in for time here into this equation, 20 equals v naught cosine 32 times the time, and we can solve for v naught, which the question is asking for. So we're going to do 20 is equal to v naught cos 32 times the time, 1.42, and then we get the answer that our velocity was 16.6 meters per second. Okay, the key to this problem, again, you're stuck until you can look at your components and think about them in terms of the resultant, the initial velocity that's coming off at that angle, because otherwise you would be stuck and you cannot find another equation and you wouldn't be able to solve. That's why, thinking back to our last check-in, it wasn't good enough to just say mgx and mgy. You needed to say mg cosine of the angle and mg sine of the angle. Break it down as